Alright, hey everyone. So this is a review video for Lab 1. Um, make sure my mic and everything is working correctly. So I just want to make a couple of notes on the review videos and the grades. So one of the reasons that everything is I held off on grading and doing these as long as I could is because if you haven't done it already, this is the last, this is like the point of no return. So, those of you that turn your labs in, I still am missing a couple labs from each class. So, I'm just assuming that you were unable to purchase your books or whatever, and I apologize. I understand how it goes. We have to make priorities. So, if you try to turn in your labs after these videos are posted, number one, you don't get credit for the problems that we reviewed. And I mean, the late penalty, you're automatically looking at about 50%. So just be forewarned, as I do these videos, I'm closing the book on the labs as I do them. So I tried to wait as long as I could. Now, you don't have your grades for a couple of other reasons, myself included, mostly to blame, but I will be catching those up this week. That's why I gave everybody a break. Give myself a break from having to do that and having to focus on everything that's going on here. So, with that being said, let's get into the review for Lab 1, which was Chemistry and Measurements Lab. So let me pull. This is the content that my lab classes received. Now, there was some confusion, I guess, about what this burette reading was. Okay, now the burette reading, let me pull up the lab manual real quick. Lab 1, lab manual. Okay. Oh, I gotta say, hold on just a second. Which one would it be? Here. Okay. So this was the lab that was completed, and for the most part, everybody did really well. There was a couple of confusions with the measuring of lines. We'll go over that here shortly, but I just wanted to mention the graduated cylinder that you were looking at, and I guess I wasn't clear enough, so I might go back in there and add some points or just give everybody credit for these points here. So if I made a note on your thing, on your lab report about this particular problem, now that I've been going over it, I may not have been clear enough about what this is, especially like in my walkthrough video. So this was the displacement. Okay, right here on your lab report, part B, volume of solid by displacement, and you have the initial volume of water, and then you have the volume of water and submerged solid. And I think where everybody got confused, where some people got confused, was this one says initial and final, and it doesn't show the submerged metal. So it might have been confusing. Some of you may have looked at this and what does this even mean? This should have had part B or something tied to it, to this image, so that you would know where to reference on your lab report. With that being said, most of you got it right. All right, most of you still did the right thing. Some of you pulled numbers from somewhere else. Must have been a similar source. I'm not real sure. So, with that being said, let me talk about what is going on here with displacement. All right, let me pull up my iPad. Notice here that you have an initial and a final. So what's happening is I am putting. Let me get a little pen. I've got two graduated cylinders, right? One is at this level now, and that's the initial, and then the second one is at this level, and it's got some little metal object here. Okay. Oh my gosh, this thing is so sticky. Hold on just a second. Metal. For some reason, this stylus is just grabbing onto this pad. Um, okay, so what happens is when I place the metal into this cylinder here, the water level is going to rise up. All right. Now, let's say this is 10 milliliters and this is 15 milliliters. Okay. So what displacement tells us is the level that the water rose is the volume of the object that's in the water that was displaced. Okay, that's what displacement is. Displacement means I put something in there and that space is displaced and altered, right? In this case, the water level rises because there's something in the bottom that takes up that much space. All right, so this is displacement. The difference in these two values, 15 and 10, 5 milliliters, right? 15 minus 10, that equals the metal. That's the volume of the metal. All right. So in the case of your lab, what you should have done is read this burette right here. I would read the first one as 9.65. Okay, and I'm going to talk about that. I always add another significant digit to a measured number. That's called the estimated digit. Some of you were mistaken about what that was. So we'll come back to that. Let me finish on displacement. So I would read the first one as 9.65. I would read the second one as, I ain't got it as clear. Let me pull it up on my screen. 24.15. Okay, let me write this on my little pad. 24.15, and that's in milliliters, right? That's also not mentioned here. So, like I said, I'll add some credit onto everybody's, I assume. And those of you that got it right will probably just end up being like a bonus point for you. 9.65 on the other. You can tell I'm still kind of grappling with this in my head. Okay, so let me bring y'all this iPad. These were the values, right? This was the final. I'm still sticking I apologize. Initial right here. Okay, so I subtract those. 0, 5. I want to leave that significant digit though because both of these were significant. Okay, I want to leave this 0 here. I don't want to take it off because that adds accuracy to my result. So what we do, 3, 9 is 4, 1. About 14.50 milliliters is what you should have came up with the volume for the object. So I'm going to pull y'all back to the page. Where's that at? Right here. Okay, so you should have had initial volume as 9.65, the volume of water in submerged solid as 24.15, or a better estimate. And so you'll see when we get to the measurements, I want you to add that significant figure. That's the estimated digit. We'll talk about that here in just a second. And then the volume of the solid we just said was 24.15 minus 9.65. Right, equals 14.50 milliliters. That's what would go in number 4 for the volume of the solid. All right, so let's go back to measured numbers, and I want to make a note about some things that people messed up here. So people took the width of their fingernail, the distance around your wrist, the length of your shoe, the length of this line, right? All of these different measurements that you do with your eyes, okay? Kind of like we just did with these readings here, right? I looked at this with my eyes and I said, well, it's about 9.6, but I want to add an extra significant digit. So what we as scientists do, and one of the rules for measured numbers, right, that we've been looking at, is to add a estimated digit. Okay, so the estimated digit is technically going to be like the last significant digit that is in your value. Okay, and let me explain that real quick. Let me pull up my iPad. Where's my iPad? Okay. So, for example, on the problems that you did in your lab, it would give you a number. It'd say 4,500, and you tell me what the estimated digit is. Okay, a good way to kind of find this is to say which numbers are significant. Okay, in this value, the 4 and the 5 are the only significant values. Okay, this zeros here are not significant. So I can assume that they're, without a doubt, that's an estimation, right? You wouldn't just round off at 4,500. If it was exactly 4,500, you would say 4,500.0, and that makes all of these zeros significant. But since it doesn't have that decimal there, these are rounded numbers. It's been rounded up to or down to 4,500, and you ask yourself which was the one that was estimated. Well, if it was 40, let's say 44.99 or 44.50 or 45, oh, excuse me, 45.15. Say these are all of the different values that I was looking at, and then I said I want to round to the best number. I ended up going to 4,500, right? Um, so the 5 is essentially the one that is the estimated value, okay? Because it could have been 44, it could have been 45, but it was right on that border, so I said it was 4,500. The 500 is essentially the whole estimate, the estimated number, all right? Let's look at another one. So if it were, let's say 12.50, right? All of these are significant. Okay, so then that means none of these here were estimated. Let me back up just a second. We know that none of these were estimated because this zero adds the significance. So the way I look at an estimated digit is go to the last significant figure. That's the estimated digit. Okay? I can assume that there was probably something here that was like 499, 498. That should be a 4, sorry, sticking again. 498, whatever. And then I rounded all of that to 12.50. Okay? So the last estimate, the estimated digit here would be the 0. I just think of it as the last significant figure. That's where the estimation stops. Okay, so let's talk about why that is and how you do it in practice, like with a ruler. Because you'll notice on some of your lab reports, I said that all measured numbers need to end in 0 or 5. Okay, so let's explain why that is. Looking at, I pulled this up to say these are measured numbers. Okay, if I just went by the lines, I would say it would end on the 10th place, so 9.6. 24.6 or 24.7. I'd use one of those. Okay, so let's write those down. 24.6, 24.7. I could call it either one of those. Now, the best thing to do to add some significance to it is to guesstimate whether or not that line is right on 24.6, right on 24.7, or right in between. And so what I will do, if it's right on 24.6, I'll add a 0. Okay? If it's right on 24.7, I'll add a 0. If it's in between 24.6 and 24.7, I'll make it 24.65. Okay? So this adds, all of these become significant digits. I increase the number of significant digits when I go to do calculations. That makes my results more accurate. Okay? So that's why I also said that it always has to end in a 0 or a 5 if you're the one taking the measurement. Because I don't want you saying, it looks like about 24.62, because you're really guessing then, right? If it's somewhere on that side of a half, So what we do as scientists, we just say it's either dead on the line or it's in between. If it's in between, we call it 24.65. If it's dead on the line, we'll use one of these. Okay? So that's how you take a measured number. So for example, where's the lab manual? For example, on this one where you took the length of a line, if I measured this out in centimeters, and I was a little lenient on some of these because I don't know how you're measuring these things, what your increments are on your ruler or whatever, but I wanted to see about 3 or 4 significant figures. Maybe 3 if it was just like 5.45 centimeters. Okay, but I still wanted to see that extra added 0 or 5 in between the increments so that you have that extra significant figure. Okay, so let's do like little quick kind of practice, and just to make sure you got it. Okay, so I'm going to draw my own ruler here. Let's make little marks. 1, 2, 3, 4. Okay, so it says 1, 2, 3, 4 centimeters. All right. And now I'm measuring a line right here. Then I'm measuring a line. Let's say I measure 2 different lines. This one here. Okay. So, and I ask you how many centimeters is line 1? And this bottom will be line 2. Okay, how many centimeters is line 1? All right, if I just use what the ruler has, I had to say 2 or 3. Okay, but I'm not going to do that because I'm a scientist and I want to be specific and accurate. All right, so what I'm going to do is call it, let's say 2.5. All right, so just that one little bit makes that number so much more accurate, right? If I just called it 2, I'm really not on the 2. If I just called it 3, it's definitely shorter than 3. 2.5 is a much more accurate number. Okay, so now let's go to line number 2. This one kind of falls on the 3, right? So I could just say 3, but as a scientist, that's not that accurate. If somebody looks at this and they say that's the estimated digit, then they're going to say, well, it could have been 2.5, it could have been 3.4, it could have been all these other things actually. So I'm going to be a little more specific, and I'm going to say it's right on the line, 3.0. All right, so it should always end in a 0 or 5, but you're just guessing in between which lines it is, right? Some rulers will have this one. If you got that line, then you can start guesstimating 1.75 right in between, right? So there's different ways, and it really depends on your ruler. That's why I said I gave a little more credit on that part because I didn't know what you were using. But there's ways to increase the accuracy and the number of significant digits when you're doing a measured number. And that's what this lab was kind of about. It was kind of expressing how you, or showing you how to express numbers more accurately, more precisely, because that's what science needs to be accurate. All right. So, that being said, let's go back to the paper and see. There's a couple more problems. Significant figures. A few people missed some of these, so I'll kind of touch on this. I just mentioned it on one other ones, but for this problem here, okay, none of these zeros on this side are significant. Okay, there's only one sig fig, and I use SF for sig fig. There's only one sig fig here, all right, and that's because, think about it in terms of scientific notation, right? If I were doing this in scientific notation, it would be 4 times 10 to the negative 1, 2, 3, 4. Okay, those little dots are just me counting backwards from decimal. That's how I taught y'all. I'm pretty sure that's how I taught y'all to do it. So I only have one significant figure here, and all I've done is change where that decimal is. Now, in the other case, like we had another one that was 625, well, excuse me, 625.000. Okay? There's 6 significant figures here. All right, the reason there's 6 significant figures is because these zeros lie behind the decimal and there's a significant figure in front of them. Okay, that was supposed to be an arrow. God, that was awful. I don't know what's wrong with this pen today. If there's a significant figure in front of the zeros and the zeros are behind the decimal, then those are also significant. Note right on this one, I didn't have any significant figures over here on this side of the zero. If I did, that makes every zero there significant, right? If this was 50.0004, I'd have 1, 2, 3, 4, 5, 6 significant figures, but it's not. Okay, so having this little significant figure in front of the zeros means everything. All right, so back to 625.000. If I were to write this one in scientific notation, I have to leave those zeros in because they're significant. All right, that's when you do your scientific notation, it includes all of the significant figures. So I'd say 625.000 times 10 to the second. Okay? And I still have 6 significant figures here. So kind of pay attention to that. Some of you got mixed up and had all of the zeros on the first one and none of the zeros on the second. Might have got it backwards, but so just pay attention to that. Well, there'll be some more of this on the midterm, and it's also important when you start writing these bigger numbers that you have the right number of significant figures in your scientific notation. Okay. There's definitely something else I wanted to look at. Let me see. So the last part was just, sorry, I got lost. The estimated digit, okay? So on the estimated digit, and it wasn't as clear about it in your book, the last significant figure, I can't think if this is just absolutely true or not, but a general rule of thumb is the last significant figure is the estimated digit. Okay? I think that it works in all of these cases, I know. I can't think of an example where it doesn't work. Yeah, I think it will work in all of these too. So the last significant figure, let me make sure y'all still seeing what I'm saying. The last significant figure in 625.000 is that last little zero in the thousandths place. Okay? The last significant figure here is this zero in the tenths place. That would be the estimated digit. Yeah, I think that works that way. So anyway, that's it for lab 1. I'm working on lab 2 now. I should have that video also posted by the end of the day. So remember what I said about having those turned in. If you're one of the people that just have not been able to get these done for whatever reason, you need to email me, let me know what's going on. This is, like I said, you're past the point of no return once I do these videos. Okay, so I'm kind of locking you out. You can still send it in. You might only get like 50% or something. You can't get credit for the ones that I just did, except for those ones that I said I was going to give as bonus points. But yeah, I hope you. I hope you're not falling behind, thinking that you'll be able to turn all this in at the last minute, uh, your grade's going to suffer. Okay, so just know that, and you have been warned. So that's it for right now. I'll see y'all later on this next video. Email me if you have any questions, or if there's other certain problems you want to review, or if there's something that we did here that you didn't quite understand. I'll see y'all later. Bye.